This lesson is to find the area of a triangle when we don't know the height of the triangle. We're going to do this by using the sine of an angle in the triangle and two of its sides. So I'm going to draw, I have an acute triangle shown here as well as a triangle with an obtuse angle in it. And I'm going to draw in the height on both of these triangles. So the height on the triangle with the obtuse angle is outside of the triangle. So with this in mind, I'm going to use the sine of angle A, and I'm going back to right triangle trig here. But the sine of angle A is going to be the height of the triangle divided by the hypotenuse, which is side C in this case. And so I can come up with an expression for the height of our triangle by saying it's side C times the sine of angle A, and that's going to give us our height. Now, we know that the formula for the area of a triangle, I'll write in this box, the area is 1/2 the base times the height of the triangle. And so this is why we need to have an expression or be able to come up with the height, because normally when we're talking about our problems, we don't actually deal with the height. So we want to be able to use what we know and come up with an expression for the height real easy. So based on this, I'm going to substitute my expression for the height into the formula. So area equals 1/2, and the way I've labeled this triangle, I've put side B as my base, so I can write B for the base times the height, and I'm just going to use this expression that we solved for, C times the sine of A. Okay, so in our obtuse, with our obtuse angle, again, I'm going to do the same thing. This hypotenuse of this right angle that I have created over here is side C, and we'll call the height H. And so again, I'm going to use the sine of angle A within my right triangle over here. So again, you'll notice that the sine of angle A is equal to the opposite side, which is our height of our triangle, divided by the hypotenuse, which in this case is side C. And so I find out that the height of our triangle, again, is C times the sine of angle A, and that'll be our height. So you notice it doesn't matter if our triangle has 3 acute angles or if it has an obtuse angle in it. We can still come up with an expression for the height by using the sine of one of the angles. Okay, now another thing that we're going to have to remember as we try to solve some triangles is that the sine of an angle, let's call it the sine of theta, is equal to the sine of its supplementary angle. So it's equal to 180 degrees minus theta. So the sine of an acute angle is also equal to the sine of its supplementary angle. So I can, if I had drawn, the orientation of this triangle differently, I could have come to the same conclusions, but it wouldn't necessarily be side B times side C times the sine of A. Maybe I know like angle B or I know angle C. All I would have to do is draw that triangle in a different orientation, and I would find out that the area is also equal to 2 sides times the sine of the other angle, or the angle between the 2 sides. So there's sort of a pattern that goes on here. Notice we're using an A, a B, and a C, A and a B and a C. So it also works that if we know side A and side C, we would need to know the sine of angle B, and we could use all of these, any of these configurations, and come up with the area of a triangle. So we can say in words, instead of having all these formulas and configurations, we can say that the area of a triangle is equal to 1/2 the product of two of the sides of the triangle times the sine of the included angle between the two sides. So here's an example. We're given a triangle that has an obtuse angle in it, and we're going to keep in mind that the height of this triangle, again, is outside of the triangle, but that's okay because the height is the height. It's 1/2 base times height. And remember that this supplementary angle, the 127 degrees, is supplementary to our angle, what we used as angle A in the previous example. So because the sine of 53 degrees and the sine of 127 degrees are equal, we can just go ahead and use the sine of 127 degrees. So again, area equals, and we have, it's this triangle DEF, so we're just going to call it 1/2 the product of the two sides, so 9 times 12 times the sine of the angle in between those two sides. And when we do that, we find out that the area here is 43.126 feet squared. Okay, so here's another example where we're given two angles and only one side. So I'm going to draw this triangle and label it. It says side A is 32.5 centimeters. Angle C, and this is going to be kind of tough to work with me here, 73 degrees, 30 minutes, and angle B is 58 degrees. So if you recall, previously we said that the area of a triangle is equal to the two sides, the product, 1/2 the product of two sides times the included angle. Well, in this case, we're only given one side, and we're missing that corresponding angle to side A that we have here. So we're going to have to use the law of sines to find out another side length, and we can easily find out angle A by doing 180 degrees minus the sum of angle B and C, and B plus C, and just to make it short, we'll find out that that angle A is 48 degrees and 20 minutes. Okay, so now we have angle A and we can have side A, and we want to find either side B or C, and I think I'll find side B over here. So B is to the sine of 58 degrees as side A, 32.5, is to sine of angle A, the sine of 48 degrees, 20 minutes. And when we do all that calculation then, we will find out that side B is equal to 36.962 centimeters. Okay, so now I have two sides and I have the included angle, and so now I can find the area. Area equals 1/2 side B, and I'm going to have that in my calculator, so I'm going to write it like this, times side A, which is 32.5 centimeters, and then times the sine of the angle included between those two sides. So 73 degrees, 30 minutes. And when I do all that calculation, I find out that the area is equal to 575.898 centimeters squared. So it's pretty straightforward. Thanks for listening, and I'll answer questions in class.